You are staring at a massive, sprawling code base, maybe hundreds of thousands of lines of code, dozens of interconnected systems, and there is completely unknown bug wrecking your program. You have no idea where it started, and looking at logs is about as helpful as reading tea leaves. How do you survive when the project is so massive you don't even know where to begin? Let's call it a disappearing act. When you are lost in a giant architecture, don't try to read everything. You will drive yourself crazy. Instead, your core strategy is to identify the general area and start relentlessly chopping. You comment out function calls, you disable entire features, you bypass whole rendering passes or physics updates. You just keep ripping things out, step by step, testing after each cut. Until, poof, the problem suddenly disappears. Yes, your game or app is probably completely broken at this point because you disabled half the engine, but that doesn't matter. The exact moment that specific bug vanishes, you have won. You have just isolated the culprit. You force the bug to show you exactly in which neighborhood it lives in. Once you know the neighborhood, you can grab your magnifying glass. You might be looking at the code I have on screen right now, our nice little C++ pixel game engine demo with the red ball and the green platform, and thinking, hey, that's not a massive code base. And you are exactly right, but let's start slowly. In a few minutes, we are going to use this little gravity simulation to deep dive into the micro-level hunt, because there is a very specific nasty little math bug hiding in that collision detection code. This video was proposed by you, Philip0A98. Thanks. If you want to see something specific, don't hesitate to drop a comment. So, we leave the chaos of the massive architecture and come down to something like this small C++ demo. The ball is falling, hitting the platform, but instead of staying on top of it, it's weirdly glitching inside. Here, the challenge completely flips on its head. In a small project, or once you've isolated a bug in a large one, the difficulty isn't finding the code anymore. I know exactly where my collision detection is. It's right there in the update function. The real challenge here is through understanding. When you stare at the tiny block of code that you wrote, your brain plays a very dangerous trick on you. You have to force yourself to read what the code is actually doing, rather than what you intended it to do. It sounds simple, but it is incredibly difficult. You will look right at the broken line of math and your brain will autocorrect it because you know what it's supposed to mean. Take our circle and platform collision, for example. I wanted to calculate the distance between the closest point on the platform and the center of the circle. To keep things fast and avoid an expensive square root calculation, I calculated the square distance. It is a standard everyday optimization. My brain looks at the logic checking if the distance is less than the radius, and it just nods along. It looks perfect, but it isn't. My intention is masking the reality of what I actually typed, and until I can break that illusion, I will never fix the bug. To break that illusion, we can't just stare at the screen. We need tools. Before we start blindly stepping through this C++ demo, let's talk about the weapons we have for the hunt. The obvious first choices are the tools built in right into your IDE. Breakpoints are our best friends. You drop an anchor in the code, stop time, and look around. You learn to step over functions you know are safe and step into the ones you suspect are lying to you. And just as importantly, you set up watch windows. Don't just hover over variables hoping for a tooltip. Explicitly tell your debugger to keep a constant eye on variables like f-squared distance, so you can watch exactly how and when they betray you. But I also want to take a moment to defend a technique that gets a lot of unfair hate: print debugging. Some purists will tell you that if you are writing stdcout or printf to find a bug, you are doing it wrong. There are times when print debugging isn't just useful, it is strictly necessary. Sometimes a bug only happens in a highly optimized release build where your debugger can't attach properly, or the variables are optimized away. Or more importantly, for game development and physics loops like ours, you have real-time scenarios where the very act of pausing the execution with a breakpoint fundamentally changes the state of the app. If you freeze a physics simulation to check a collision, you might ruin the elapsed time calculation. causing the bug to vanish or behave entirely differently. In those moments, printing a rapid-fire log of your variables as the game runs is the only way to see the through without disturbing the crime scene. Now that our toolkit is ready, we move to the micro hunt. We are looking for the exact line of code where the logic breaks down. There are two main parts here, control flow and data flow. Control flow is about watching where the execution goes. In our gravity demo, the red circle is sinking deep into the green platform before it finally stops and rests. So we drop a breakpoint right in our collision if statement to see what is happening. If that breakpoint never hits, we know the collision logic is being skipped entirely. In our case, it does hit, it just hits way too late. That tells us our control flow is reaching the right place, but the condition triggering it is fundamentally wrong. This means we have to switch our focus to tracking the data flow. We need to start looking at the variables themselves and trace their computation backward to see where the math originally failed. We look at our watch window and see if circ radius. It's sitting there at exactly 15, just like we set it. Then we look at the squared distance. When the ball first visually touches the platform, the true distance is 15, making the square distance 225. And suddenly, staring at those live numbers in the debugger, the illusion shatters. The code says, if the square distance is less than or equal to the circular radius. We are comparing a squared distance of 225 against unsquared radius of 15. It completely ignores the collision until the square distance shrinks down to 15, meaning the ball has to sink until its center is barely 4 pixels away from the platform's edge. We found the exact line. The data flow revealed a math error that our eyes kept autocorrecting and skipping right over. Let's talk about a bigger project. This is one of my older ones, Pacman in 3D in DirectX 11. When I run it, play for a while and get attacked, something weird happens. The dying animation happens, detailing the visual bug, but the game just continues. Let's hunt. If you have no idea what you are looking at and want to understand a little bit of the background, start in the main function, or winmain in this case. We can see the window creation and the message loop, pretty standard. In the loop, there is a tick function. Usually, this is where the moving parts are, so let's dive in. You can use Ctrl-click to follow it. Here we can see a timer calling and update function as a lambda. I don't think the issue will be in the timer, so let's continue to update. Here I can see state handling, and that might be interesting. Let me check the enum. As it seems, the game might be in 4 states: intro, start, level, or dead. We are not sure what it means quite yet, but is it possible that our issue is somehow connected to the game being in the dead state? Now, I will take a pen and paper and write it down. This function looks interesting. Is dead. It's asking the Pacman object. I can see it checks a variable called isDead. The variable is set here, so maybe this method is not getting called? Down there, I can see more things like movement handling and eating dots, but nothing suspicious. However, right at the bottom, there is a collision handling call. That sounds really interesting, since the issue really appears after a collision between Pacman and a ghost. So here for each ghost, I'm computing the distance between it and Pacman. And if the distance is small enough, I'm checking if the ghost is frightened. This might mean it is blue and ready to be eaten after the player ate an energizer. And if not, wow, I can see the issue. I commented out the setDead call. Let me fix it and try again. Great. What you can also try is to directly search for keywords. If the project was written by a sensible person, and looking at the macros, you might say this one wasn't, but hey, I could assume that the issue will be somewhere in the method solving collisions. So hit Ctrl-Shift-F, write collisions, and look at that, a method called handle collisions. That would be a pretty good place to start, and that is something you should definitely try as a first thing when working on a big project and you just need to fix something fast. Debugging is an absolute exercise in patience. It is not about writing code. It is about forensic science. You are a detective, and frequently a criminal too, at a crime scene. And if you are go stomping around, changing everything at once, you are going to destroy the evidence. This brings us to the golden rule of debugging: slow iteration. You must slowly and methodically iterate toward finding the problem. You change exactly one thing and then you test. You remove one function call and you test. You fix one squared distance calculation and you test. If you rush, if you get frustrated and start changing 3 or 4 variables at the time, hoping one of them magically fixes the issue, you will get completely lost. You might even accidentally fix the original bug, but introduce 2 new ones in the process. You won't know which change did what. So slow down, change one thing, observe the result, and trust the process. That is how you win the hand, no matter how big or small the project is. If you are interested in general programming tips and tricks, check out this video where I'm talking about big picture perspectives. Thanks for watching. If you like what you saw and want to see more in the future, don't forget to hit the subscribe button. Ciao!